This is a demonstration of the OD5000 displacement sensor from SICK. In this particular application, I have several different parts, and instead of measuring the thickness of each part, I really don't care how thick they are. I just want to count them. So as I move pieces off, I have a stack of washers here, and as I move them off, I want to know how many I've removed. Is basically the idea in this application. So what you're seeing here is the Sopus Air interface of this. So I go to a web browser, I type in the IP address. In this case, I've changed it to 192.168.1.200, and it opens the Sopus Air configuration. And the first thing that you're going to see is actually the monitoring tab. So it's given me a reading of what it's doing, and also the 4 different channels that I can set up down below. And if these channels are on, they're red. If they're gray, they're off. And also, actually, the first thing that you're going to see is as I go to different tabs, everything is grayed out. So the first thing you have to do if you want to change something is come down to the bottom left and click Run and go into Maintenance. The password is MAIN, all lowercase. And then at the top right, hit the pencil. So once that's done, now I can go into the measurement tab and I can change settings. So for this demonstration, I'm going to use 2 of these channels. So A is already configured. I'm going to click B and configure that one as well. Again, if I hit measured values, it's going to give me the actual value that the sensor is outputting. And I'm just going to click Teach 0 point for both of them right now. Okay. Also going to say under mounting, I want to make sure I'm diffuse. And then the cycle time, I'm going to change that to as long of a cycle time as possible, just for best performance. So I'm going to make that 1,000 microseconds or 1 millisecond. And then that's all you should have to change on this screen. Now if I go into A and B, I have a couple of different things that I can modify. I am going to change the average filter. The default is 256. I'm just going to turn that up a little. Just takes a little bit of extra noise out, makes it more repeatable. And I'm going to do the same thing with the average filter for channel B as well. The other thing to notice on here is the error mode. It's set to user-defined value and 1,000. So again, look at the measured value here, and if there's any kind of error or if I go out of range, you're going to see that 1,000 pop up, or whatever value you put in that error substitute distance. So if you either see this value pop up, then you know there's some kind of an error or you're out of range. And then that's all there is to that. So now if I go into the I/O channels, here's where for A and B or the other channels, I can set up a window mode. I can set the lower, the upper limit, and also the hysteresis. So to know what that is, again, for this application, I don't really care what the actual thickness is. So it doesn't really matter in this case. If I'm doing it this way, it doesn't really matter if the sensor is perfectly aligned, perpendicular to the target, because I can get around that with more of a relative measurement. So what I'm going to do here is, again, I've already zeroed them out, and if I take away 14 of these washers, now I'm looking at the last washer, and it's giving me a distance of 16.23. So 16.23 divided by 14 washers. So each washer is about 1.16 millimeters thick. Measuring these washers with calipers, they're about 1.19-ish or so. But again, I'm using I'm trying to get rid of any error this sensor has. So for this type of application, to me, this is the best way of doing it. So using this method, again, the thickness of the washer, of each washer, is about 1.16. So in order to find out what type of window that I need, I'm going to take that 1.16 and cut it in half, which is 0.58. So I'm going to make the window plus minus 0.5. Let's make it plus minus 0.5 millimeters around what it should be. So if I take 14 washers off, it's telling me it's 16.23. So I'm going to do plus minus 0.5 of that. So 16.23 plus 0.5 is 16.73. And then 15.73. So that's my window. And I'm just going to make that hysteresis, I don't know, 0.1. I'll just give it a little bit of hysteresis so the output doesn't ever flicker. So that should be A. So now if I go to monitoring, I see that channel A is on because I'm looking at the last washer. So put another washer on it. Channel A should go off. So channel A is off if there are 2 washers. And then if there are no washers left, it's also off. But as soon as I have 1 washer in there, if I can find the laser again, then channel A is on. So let's put more on these and we'll set up channel B. So now I've taken, there are 10 washers on there. Channel A is for 14 washers taken away, and channel B is for 5 washers taken away. So with 5 washers taken away, that's 16.23, and I'm sorry, let's do that again, 1.16 times 5. So I should be seeing a value of about 5.8, and that's what it's showing me up here, 5.85. So I go into IO channels, go into channel B, and I'll set this. So 5.8 plus 0.5 is 6.3. 5.3 to 6.3. Oh, I didn't like that. Do the upper limit first if it ever jumps like that. So 5.3 to 6.3, and then I'll leave the hysteresis there. So now if I go back to monitoring, channel B is on when 5 washers are removed. So this is just a way to show quickly that it's working properly, or you can just look at the actual measured value and just say for whatever thickness of the part that you came up with, multiply it by how many have been taken off, and it should reflect that here. This is just kind of saying, hey, when you send this measured value into your PLC, you can set up little windows like this and do it this way. And, you know, so if it's within this window, then I know that 5 pieces have been taken off. If it's within different windows, then those correspond to different numbers of parts taken off. So that's really all there is to it. If you want to add any kind of timer delay, you would do that here. You don't really need any calibration because of the process that we went through on measuring the thickness. We didn't really care about the actual thickness of the part. We just did a relative value based on what the sensor, the data the sensor was giving you, and that gives you a much better, much more reliable signal. So that should be all there is to it for this demonstration, and let us know if you have any questions.